Let's talk about operator overloading. So, operator overloading is where you take one of the built-in operators in the language, like plus or and or anything else, and you give it a meaning for a type other than one of the built-in types. So, you've probably used this already if you've written any code in C++. It has a variety of different useful purposes. One of them is allowing you to create custom types that you can use like a built-in type. So for example, you could, the string type. String is defined in the standard library, but it is defined just in the same C++ language that you write your own code in. So it follows the same rules, but you can concatenate strings together with the plus operator. You can assign strings. Assignment is an operator just as much as anything else in C++. And that works because it provides operator overloads. Another one that I briefly introduced, smart pointers, which I briefly noted that you can use just like pointers. So it's a class that wraps a pointer and gives you a bunch of other functionality, but you can use it just like a pointer. If you have shared ptr to some type A, let's call that A, you can do a foo, assuming there's a member method called foo in the class A. You can use it just as if it was a pointer, but this is a class. You can also access the value by prefixing it with a star, just like a pointer. And those, the way it works is those are both operators that are overloaded by that class. Another reason it's commonly used, as opposed to trying to imitate a built-in type, is just to make syntax a lot simpler and cleaner. So one very prominent example is if you've ever written anything to standard output in C++, not using the C APIs, but using the C++ APIs, you're probably familiar with something like this. So cout is the console output stream. Then you have what's actually a left bit shift operator, but it's very clearly not being used to shift bits here, and something like that. So what we're doing here is the standard library provides an overload of that operator that has on the left an output stream and on the right a string, and has a necessary implementation in order to write that string to that output stream. And the result of that is the same stream, so that's why we can then just append more data that we're writing out with the same bit shift operator. Right. So how do we actually define a operator overload for our for a certain type we want to make? So let me actually make a semi-useful type here. Actually, I'm going to make it a struct because we call it vec2d. It's going to have that's our entire type definition. Okay. So we can actually initialize an instance of this. Let's call it v. Say 3, 7.5, and I'm going to make another one called w. That's at 4, -2. I don't know, arbitrary numbers. Now what I want to be able to do is I want to be able to make one called u, which is equal to v plus w. So in order to provide that functionality, what I need to do then is define a function called operator plus. no space at all in between there, just operator plus. The resulting, or the return type is going to be vec2d. It'll have two parameters because it takes a vec2d, and a vec2d is the two operands. Let's say A and vec2d, B. And I will define it as return. It's implicit that it's initializing a vec2d because that's the context here is this needs to return an object of type vec2d, and I'm saying a dot x plus b dot x, a dot y plus b dot y. No weird vector space here. And that tells us that tells the compiler how adding anything where the left side can be implicitly converted to a vector and the right side can be implicitly converted to a vector. The result will be a vector. This is how you construct it. Does that make sense? And this is, apart from the special name, which operator is a keyword, that's special syntax. Apart from the name, the rest of the function can be whatever you want. Restriction is you can't have two primitive types here. You can't define your custom operators that only operate on primitive types. Like you can't redefine how you can add an int to a float. That's built in to the language itself. You can't override that. But as long as at least one of the types is a oh, and reminder that a pointer to any type is considered a primitive type. So you can't, because addition's already defined for two pointers, you can't redefine how adding two pointers together works. But as long as at least one of the types is a custom type, custom just meaning like a class or a struct, then you can define addition, subtraction, multiplication, division, modulo, and so forth. There's one other way that you can do it. You can define that inside the class struct as a member function, which may be useful for a variety of reasons. And you can, or in that case, you would, for the case of a binary operator, because this is operating on two values, right? It's this plus that. You'd only put the second thing in the parameter list, and this object, like the current object that gets invoked on, is the first object. And if you were defining the unary plus, for example, because you can define what plus x means for x being a variable of a custom type. For any unary operator, you only provide one parameter, or in the case where you're defining it as a member function, you don't provide any parameters because this parameter is the operand. A couple interesting special cases. Pre and post increment. So you are probably familiar that x plus plus is not the same as plus plus x, and same for minus minus and minus minus, right? So how you differentiate, because those are both unary operators, how you differentiate between them is this. The pre-increment is invoked as plus x, that's equivalent to that, or x dot operator plus, whichever is available, whereas that one is invoked as operator plus x comma 0. That's what they decided in order to allow you to overload either one. So if you want to overload the pre-increment, you just define it normally as a unary operator overload. If you want to override the post-increment, you just give it a second parameter of type int, and you ignore it, and it works. Because calling that, it will not match a function that only takes one parameter. It will have to match a function that takes two parameters, where the second one, 0, is a valid value for it. there are a couple operators that must be member functions, and they're kind of special in other ways. There's assignment, which is just special because it's used a lot, and it kind of makes sense that it has to be defined as sort of the part of the class itself because it's very analogous to a constructor, and often you will have some overlap there. I'll talk more in the next session about why we'd want to overload assignment operators, but sometimes people come up with ideas where they say, oh, this is something I could do that's really cool with assignment operators. One that's in prose, for example, is if I do prose motor, say, call it D, on port 7, I can do D equals 127. And that will set it to full throttle forward, just with the assignment operator. Because they overload the assignment operator that when taking an integer on the right-hand side, will use that as a volt, not a voltage in like units of volts, but like a relative voltage value. There is not a consensus among C++ programmers about whether that's a good idea or a very, very bad idea, because it could get confused with actual assignment, where you're logically overwriting what the thing on the left is representing. I try to avoid doing that, but that is something that's built into prose as an example use case. Another operator that needs to be defined as a member function is dereference member, which is the pointer arrow operator, and that one's interesting in other ways. So if you're defining a dereference member operator for a type, the return value cannot be whatever you want. That's the only operator where the return value cannot be whatever you want. It has to be something that has that operator. Sort of a recursive definition. Usually that something is a pointer. Obviously, if that operator is defined for a pointer, that's what it was created for. But it could be another type that you can use like a pointer, and so forth. And so how it works when you have a custom type with that operator, so A arrow B is defined to be equivalent to A dot operator arrow recursive definition until eventually, so if this returns something that's not a pointer, then you get, and so forth, and it'll keep substituting until eventually the thing on the left of that is a pointer, and that's just built into the language, and it knows how to do that. This is the only thing you write. The language just says that is equivalent to this until we get a pointer. There's subscript, which is accessing an element of an array, so the square brackets operator. That also needs to be defined as a member function. That so the second operand for that is the thing inside the square brackets, and you can have multiple overloads of that for different types inside the square brackets. Just like any other operator, you can have multiple overloads. So yeah, actually I didn't mention that earlier, but you could have, if there's another type that would make sense to add to a vector D, you could define another overload with another type there. And then the last kind of neat one, or another neat one, is function call operator. So when you call a function, the fact that you have value and then brackets with n number of comma separated values in between, that's an operator. And you can overload that, so you can make it so an object of your type can be called like a function. And that's the only operator that you can have with any number of operands. So you can define it to have like 5 operands if when calling your type, it would make sense to be able to pass 5 parameters. Lastly, are you familiar with the concept of short-circuiting with the logical and or operators? So when you have an, let me just erase this stuff. When you have an if statement, A and B with the logical and operator, what I'll do is I'll evaluate A. If A is true, it'll evaluate B. If B is true, it'll execute the content of the if. If A is false, though, before even looking at B, it'll just skip to else, or to the end if there is no else. It will not evaluate B unless A is true. However, if this is actually an overload of the ampersand operators, those aren't both Boolean. If these are custom types, or at least one of them is a custom type, and this ends up invoking an overload of the ampersand, it does not short circuit. And that's because in order to call your function, it needs to have already evaluated both of those values because they are arguments to your function. And the same thing for the logical OR operator. It does not short circuit when it's an overloaded operator because it can't. One final short topic, conversions. So you can convert between different types in C++. Syntax, for example, where I may have done float x equals 2.7, this would result in, this expression results in the value 2, right? That's called a cast. You can define custom conversions for your type. In any class or struct, you can define a conversion from another type, and you can define a conversion to another type, depending. Those have to be member functions within the class. The way it works, if you're trying to define a conversion from another type, that's just you define a constructor with one parameter, which is that other type, and then you can then that works as a constructor, also doubles as a conversion. If you want to define a conversion to another type, then let me just get rid of this. We want to define a conversion. Say we have an int, and we want to define a conversion, for example, to Boolean, which we'll just check is the int non-zero, like the built-in conversion to Boolean for int does, right? We could say, or we would do that by saying operator bool. And then in there, we could say return x. And so that uses the built-in implicit conversion from an int to a bool, and now we have our own conversion to a bool from anything of type A, which means we could have A. We could say if A, and implicitly it would be able to convert that to a Boolean and work in the if statement. What if we want our conversion to not work implicitly? It's very simple. We just write explicit, and you have to invoke it explicitly, which would mean if we wanted to do that here, we'd have to say, we'd have to cast it to a bool explicitly. Actually, I believe this is an exception. I believe putting it in the parentheses of an if statement counts as explicitly casting to bool. Maybe wrong on that. I will have to double check. But in any other context, say if you were trying to pass it into a function that took bool as a parameter, in this case you would have to explicitly cast it to bool. And the explicit keyword also works for from conversions. So like for the single parameter constructor, if you don't want it to work as an implicit conversion, you prefix it with explicit.